Hello students, I am Mohammad Sabaj Alam, Assistant Professor in ABES Engineering College, Ghaziabad. In the last lectures, I have already explained the basic concepts of p-n junction diode and its series and parallel circuits. Now, I am going to discuss an important application of p-n junction diode, that is rectification. All of us use every day in our daily life the rectification process, or you can say rectifier circuit, in terms of mobile charger, laptop charger, or either we are using television or any electronic appliances. There is rectification process, that is majority of the electronic appliances use DC circuits, and in our daily life everywhere we have AC circuits. So, we need to convert AC signal into DC signal. Before discussing the rectification process, first of all we should know about the regulated DC power supply. What is regulated DC power supply? Regulated DC power supply is the combination of various parts like step down transformer, rectifier, filters, regulator, and at the last the supply, that is load. Starting, this is AC line, we have AC supply in our classroom or in our laboratories or in our home. Then we connect the 3 pin into the AC supply, then there is a step down transformer. Why we need step down transformer? Because generally we need 5 volt DC or low voltage DC to charge the battery of our mobile or laptop, or for any electronic appliances we need low DC voltage. If we do not use step down transformer, directly we will transfer, if we convert the AC signal into DC signal, then we will have the DC value 2 Vm upon pi, and the Vm for input signal in our house or in our laboratories is 311 volt, that is 2 into 311 upon 3.14 will be very high. However, we need only 5 volt for our mobile charger, or we need low voltage. So, we use here step down transformer. Then after step down transformer we use rectifier. Generally rectifier is bridge type full wave rectifier, and here filter is nothing, it is there are some passive components like inductor or capacitor. Inductor is connected in series and capacitor is connected in parallel for rectification process. So, there are various types of filter, and filter is nothing, filter convert the pulsated DC into the constant DC, and this is the regulator. Why we use regulator? Because if we not use regulator, and if there are fluctuating at the input side or at the load side, the output voltage will change, but we need constant DC voltage. So, we should use regulator, and there are various types of regulator, IC regulator, or we can easily use a Zener diode also here. And at the last, this is a mobile battery, or you can say laptop battery, and any electronic appliances. This is our mobile charger. This is the step down transformer, this is rectifier, this is filter, and this is voltage regulator, and at the last this is the mobile battery. Now, I am going to start the important part of the regulated DC power supply, that is rectifier. This is the rectifier. Now, first of all, what is rectification? Rectification is a process in which we convert AC signal, that is alternating signal, into the pulsated DC signal. This means the input of the rectifier circuit is the alternating signal, and output of the rectifier circuit is the pulsated DC. Why it is called pulsated? Because it is in terms of pulse, it is not constant. That is why it is called pulsated DC, and this process is known as rectification, and the circuit which perform the rectification process is called rectifier circuit. There are various types of rectifier circuits: half wave rectifier and full wave rectifier. Further, full wave rectifier are of two types: center tap transformer type full wave rectifier and bridge type full wave rectifier. I will discuss these three rectifier circuits one by one. Now, half wave rectifier. In half wave rectifier, we have a diode in series with the load resistance, and load voltage is a half wave output. Use of step down transformer is optional depending on need of step down. In half wave rectifier, if we need to step down the voltage, then we must to use a step down transformer. If we do not need to step down, then we can not can exempt the application of step down transformer. Now, what is the circuit? This is the circuit of half wave rectifier. Here I have designed a circuit without the using of step down transformer. If we need to step down the AC signal, then we can use a step down transformer also. But here this is the simple circuit, this is AC signal, and this there is a series diode, and this is the load resistance, and output of the RL is the half wave output. This is the input of the rectifier circuit, and this is the corresponding output of the half wave rectifier circuit. I am going to discuss the working of this rectifier circuit. For positive half cycle, first of all we should learn the sign convention. For positive half cycle, this is the plus and this is minus, and for negative half cycle, this is minus and this is plus. This means when the V input is for positive half cycle, then this terminal is positive and this terminal is negative. For this, the diode become, for positive half cycle, diode become forward bias, and the current will flow in the clockwise direction. And if we apply the Kirchhoff's voltage law, then here we start the Kirchhoff voltage law from this terminal and we move in the clockwise direction. Then here this is the V input, and this is the ideally voltage drop across the diode is 0, and this is minus V naught. So, V input minus V output is equal to 0. This means V output is equal to V input. This means the peak value of the output voltage is equal to the peak value of the input voltage ideally. If you assume this diode a practical diode, then here a voltage drop, will taken as 0.7 volt, then in this condition V output is equal to V input minus 0.7 volt. This is practically V output is equal to V input minus 7. So, this output is for the positive half cycle only. Now, for negative half cycle, the polarity of the input signal already changed, reversed. This means this terminal is minus and this terminal is plus. This means the diode become reverse bias. Reverse bias means open circuited. In this condition, current is 0, I is equal to 0. This means the output voltage across the RL is equal to 0 into R. This is equal to 0. This means output voltage is here 0 because current is 0. This means for negative half cycle, output voltage is equal to 0, and for positive half cycle, output voltage is equal to the input voltage. Now, this is the waveform, you can see. For here the diode is in forward bias, here the diode is in reverse bias, forward bias, reverse bias, forward bias and so on. This means this is the time period of the input signal, the periodicity of the input signal is 2 pi and the periodicity of the input output signal is also 2 pi, because after 2 pi radian the output signal repeats. That is why periodicity, or you can say simply time period of the output signal is equal to the time period of the input signal. This means f output is equal to f input for half wave rectifier. F output is equal to f input for half wave rectifier. This point is very important for objective questions or 2 marks question in the university examination. Now, I am going to discuss the full wave rectifier. Since full wave rectifier are of 2 types, center tap transformer type full wave rectifier and bridge type full wave rectifier. Now, first of all, center tap transformer type full wave rectifier. First of all, we should know what is center tap transformer, because students gets confused that what is the center tap transformer. So, before understand the center tap transformer, first of all we should know what is the tapping of transformer. We know that there are 2 types of winding, one is the primary winding and another one is the secondary winding. If secondary windings are divided into 2 parts, or you can say secondary voltage is divided into 2 parts, it is called tapping of transformer. Suppose there are 311 volt maximum voltage across the secondary winding, or you can say 220 volt RMS across the secondary winding. If we divide 220 RMS voltage into 2 parts, one part is the 50 volt and another one part is the 170 volt, then this is called tapping of transformer. But when we divide the secondary voltage into equally 2 parts, then it is called center tap. This means if there are 200 windings in the secondary winding, then we are divide these winding into 2 equal parts, that is one part is of 100 turns and another part is having 100 turns, that is equally 2 parts. Voltage is divided into 2 parts. If 220 volt will be divided into 2 parts, then one half voltage is 110 and another half voltage is 110 volt RMS value. So, this is called the center tap transformer. Now, this is the circuit diagram of center tap transformer. All of you guys can see here that this is the center tap transformer, CT, center tap transformer, and it is the primary winding and it is the secondary winding, and secondary winding is divided into equally 2 parts, and this is the center part, and there are 2 diodes, one diode is at this terminal and another one diode is at this terminal, and at the midpoint and this point we have connected load resistance. This is the input and this is the corresponding output. I am going to discuss the working of this rectifier, how this rectifier works. Now, first of all, center tap transformer, it is the primary winding, here 220 volt and 50 hertz single phase supply here, and it is the core of the transformer, and it is the center tap transformer. Here you can connect a load, and here it is a diode, and here also there is a diode. Since for sign convention, we should know the sign convention. For positive half cycle it is plus, it is minus, it is plus, it is minus. This means what will happen here, for positive half cycle the diode D1 will be in forward bias and it is in reverse bias. This means here this is a output voltage V output, and we will if we apply the KVL here, suppose I am going to apply KVL from this point only, this point, then what will be here? If we will apply KVL, then this is equal to V naught, and here this is, let us say the peak value of the input voltage is Vm, then this is called plus Vm, minus V naught plus V m, and if it is ideally, then voltage is taken as 0 and this is equal to 0. This implies V naught is equal to V m, where V m is the peak value of the input signal. This means here for positive half cycle D1 will gets conduct, and the direction of the current through the load resistance is from right to left only. In the similar way, for negative half cycle, the polarity will get changed, and this is the circuit, this is the single phase AC, or you can say 220 volt RMS and 50 hertz, and here this diode will be in reverse bias, and here this is the load resistance, and this diode will be in forward bias. For negative half cycle, this is the sign convention, and the diode will conduct in this loop, and this is the plus and this is the minus, and still the direction of the current is from right to left. You can see that the direction of the current in both the situations should be same. If the direction of the current through the load resistance changes, then the purpose of rectification fails. So, the precaution is that circuit should be designed such that in both cycle the direction of the current through the load resistance should be same, then we will call it pulsated DC or unidirectional signal. Now, here if we will apply KVL, suppose I am going to apply KVL in this loop, then what we will get? Here this is Vm, then Vm, and here plus V naught, because this is the V naught across the resistance, and this is equal to 0, because the voltage across the diode is 0 ideally. Now, this implies V output is equal to Vm. Here also output voltage is equal to the peak value of the input signal. In the both cases, the polarity of the output voltage is same. Okay, guys. Now, what will be the output waveform? This is the output waveform. Yes, you can see that the periodicity of the output signal is pi only here. This is the periodicity, or you can say time period. This means, and periodicity of the alternating signal is here 2 pi. What is this? This means for 2 pi radian input, there are 2 cycles at the output. This means periodicity of the output signal is pi and periodic signal of the input signal is 2 pi. What does mean it? It mean is that F output is equal to twice of F input. This means for one cycle of input signal, there are 2 cycles of output signal. Okay, guys. So, this is the corresponding input and output waveform for center tap full wave rectifier. Here D1 gets conduct, here D2 gets conduct, here D1 gets conduct, here D2 gets conduct, D1, D2 and so on. Now, I am going to discuss the next rectifier, which is bridge type full wave rectifier. Bridge type full wave rectifier. All of you know that what is Wheatstone bridge. Like Wheatstone bridge, there is a bridge type full wave rectifier. In Wheatstone bridge, there are 4 resistances P, Q, R, S, and in the same way here there are 4 diodes. There are 4 diodes. This is the circuit diagram of full wave rectifier, bridge type full wave rectifier. There are 4 diodes D1, D2, D3 and D4. This is the input and this is the output signal. Now, for positive half cycle, what will happen here? This is the sign convention, this is plus and this is minus. What will happen here? This means this terminal is plus and this terminal is minus. D4, obviously D4 is in reverse bias, here plus, this means D1 is in forward bias. Now, here since here it is a minus terminal, this means D3 is in reverse bias and D2 is in forward bias. This means these 2 parallel diodes D1 and D2 are in forward bias, and the parallel diodes D3 and D4 are in reverse bias. So, I am going to discuss the working of this circuit diagram. Now, for positive half cycle working, for positive half cycle, D1 and D2 are in forward bias, D3 and D4 are in reverse bias. Then what will happen here? Simply I take the AC signal, this is the secondary input, secondary voltage, for rectifier it is the input. Now, yes, there are 4 points, parallel diodes are in forward bias. This means these two diodes are in forward bias. Yes, these two diodes are in reverse bias, so gets open circuited, and these two terminals are for input, and here it is a load resistance RL. This means this is positive and this is negative, the direction of current are like this. And here. Now, this is the output. This means the direction of the current through the load resistance is from right to left. What will be the output voltage? If we apply the KVL, then here this is V input and it ideally 0 minus V naught equal to 0. This means V input minus V naught is equal to 0. This is equal to 0. This implies V output is equal to V input. Ideally, if we want to assume the diode practically, then what will happen? Then V output is equal to V input minus 1.4 volt. This is the output voltage for practical diodes, means for two diodes voltage drop become 1.4, here 0.7 and here 0.7, V input minus 0.7 minus V naught minus 0.7, this is equal to 0, then V output become V input minus 1.4 volt. Now, for negative half cycle what will happen? Similarly, for negative half cycle D1 and D2 are in reverse bias, D3 and D4 are in forward bias, and the circuit will like this. Here these two diode will gets conduct, and these two diode in reverse bias open circuited, and here plus and minus, the direction of current is like this, and here load resistance, and here plus and minus, this is RL, this is V naught, and here the direction of the load current is still from right to the left, and here from right to the left. This means polarity of output voltage is same in both cases, and this is the mandatory criteria. And here what is V naught? And here V naught is V input ideally, and V naught is equal to V input minus 1.4 volt. V output is equal to V input minus 1.4 volt. So, this is the working of the full wave rectifier, bridge type full wave rectifier for positive half cycle and for negative half cycle. And this here already discussed in the center tap bridge type full wave rectifier that the output frequency is the twice of the input frequency. Now, what is the difference between center tap full wave rectifier and bridge type full wave rectifier? In generally bridge type full wave rectifier we use, because in bridge type full wave rectifier application use of this transformer is not mandatory, but in case of center tap transformer we must use the center tapped transformer. So, since the size of the center tap transformer is bulk larger, so mobile charger will be heavy, and since copper wire will use more, then the weight of the mobile charger will increase and copper loss will increase, size will increase and cost will more. That is, center tap transformer mobile charger is cost higher, and in bridge type rectifier, if you use bridge type rectifier, then the charger cost is less. This means it is the cost effective, and efficiency of bridge type full wave rectifier is greater than that of center tap full wave rectifier due to the more copper loss in center tap transformer. So, this is the comparison. In generally we use bridge type full wave rectifier in any mobile charger. So, guys, this was my fifth lecture, and in the next lecture I will discuss the various parameter of rectifier circuits, various parameters. So, guys, this lecture will be very useful for you. So, see you again in the next lecture.